Hi, welcome back to Mr. Canada Maths, and now I'm going to show you how to solve percents in the form of a triangle. So, we've been talking about this NOM, this NOM, so this new amount, original amount, or multiplier. Sometimes I call them the new and the old, just kind of interchangeably. So, one thing you have to know about these style of triangles, we see them a lot pop up with when you want to say do speed is distance over time, right? So you'd have speed, you'd have distance, you'd have time. Eventually, I'll use them for trigonometry, for sine, cosine, and tangent. Okay, so what they do though, I sometimes call them calculation triangles or just the speed, distance, time triangle. Is what they do is they allow us to kind of always set up and put the numbers in where we have them, and the triangle will take care of whether we have to multiply or divide. So we don't have to really solve your equations out or do any of that nasty. Some people don't like doing things like 3x equals 5 over 2. They don't like solving for x, right? These triangles take care of that, so you don't have to rearrange your equations. So the triangle will do it for you. So one thing to note is that if things are stacked on top of each other, like they would be with n and m, so n over m, if we pulled it out, that looks like a fraction. N over o, that looks like a fraction, so that we divide those. Similarly, o and m, well, that's algebra. That's o times m. So there's where the signs come from. Okay, so those are your three cases. As you've seen with our last video, sometimes you can have a t up here when you're doing uh, compound percentages. So that's like compound interest, etc., or growth and decay. But don't worry about that so much right now. Just think of it as nom, and let's try a problem. So find 15% of 135. Well, we know that 15% is m equals 0.15. And then 135, well, that is our original, is 135. So, using these, and I always implore people to actually draw the triangles with like two triangles, one to set up what it is. So, normally we wouldn't just be doing percentage problems all our life. We would be doing uh, we'd be doing other problems alongside of it. So we wouldn't know that, hey, I know that every time it's NOM, right? I wouldn't always know that. So the first time I would say write that NOM in it. The second one I would say just start filling it in. So here we have our M as 0.15. We have our O as 135. And we're solving for our N. So that means between here we have multiply. Sorry, that says 1. It just doesn't look like it. Between there we have multiply. So our N is equal to 135 times 0.15, and that's 135 times 0.15, 20.25. So, how about a different one, right? Sometimes sometimes even if you don't want to draw like a super nice triangle, I sometimes just go NOM. And when I do my other triangle, I do it nicely. Just that way I can see what exactly I'm doing. So originally, we have 20 reduced. What's the percentage change? So here, we have, originally it was 20. Sorry, didn't give myself enough room. Originally it was 20. Now it's 17.5. What was M? Well, let's give my triangle some stuff, right? Even a trapezium still doesn't matter. You get the idea. So here we divide those. So our M is equal to 17.5 divided by 20. And that's going to be 0.875. So our percent is equal to 100. Subtract that 87.5. So that's 12.5%. And lastly, I bought jeans for 20% off. What were they originally? So we're looking for our O. So if we set up our triangle, we have our O, our N, our M. So we are going to substitute our values. So our N then is 1350. 20% off. So 20% off, that's 100 minus 20. So 80, which is 0.8. So 0.8. And so we know that's divide. So our O is equal to 13.5 divided by 0.8, which results in 16.88 after rounding. And I rounded off because it is money, so we can't have anything more than that.